Hello and welcome to NCRT's live session. This is Simran Singh. You're watching us through PMeVIDYA, or you can also connect with us through our YouTube channel, that is NCRT Official. In case of doubts or you want to convey anything to us, feel free to contact us on our toll-free number, that is 8800440559. So our session for today is class 12th, and the mail ID for class 12th is dth.class12@ciet.nic.in. So as I already mentioned that we will be discussing about class 12th. So our subject would be mathematics and our topic of discussion is integrals. So to have a conversation at an elaborated length, we are joined by an expert. Let me introduce her to you. We are joined by Mrs. Neenu Gupta. Hello ma'am, welcome. Ma'am, could you please unmute yourself? Hello ma'am.
Ji.
Hanji, ma'am is PGT Mathematics and is currently serving at Alcorn International School. Ma'am, we may proceed with the topic.
Yeah. Hope I'm audible, ma'am.
Yeah, you are audible. Ma'am, you may proceed.
Yeah. Hello, dear learners. In today's session, we are going to study integrals, which is one of the very basic concept and one very important concept in calculus. Let me ask you a few questions. Before that, let me tell you that in this session, we will learn integrals as antiderivatives. As you know, the derivatives are very basic concept of calculus. So now we'll study this concept to integrals as well. We'll also learn about the geometrical interpretation of integrals. Difference between differentiation and integration will also be taken, and some of the questions based on integration or some standard functions and some more functions will be taken in this session. You know this figure. This is square. How do you find its area? Its area is calculated by the formula side multiplied by side. This is rectangle. How will you calculate this area? This area is calculated by multiplying its length and breadth. Let me take you to another figure. You recognize this figure? This is circle. Its area is calculated by using the formula pi r square. This is triangle. We have multiple formulae for finding its area, like half base into height, root 3/4 side square. This is an equilateral triangle. You may also use Heron's formula. You may also use coordinate geometry's formula if you wish to find area and all three vertices of the triangle are equal. Now, which formula can be used to calculate area of the following figures? If the figure is ellipse, if you have to calculate area bounded by a parabola with a horizontal line or x-axis. How will you calculate area between two circles? How will you calculate area bounded between a modulus function and a circle? How will you calculate area between two ellipses? So, do you have any formula? No formula is existing for all these things. So, we require integral calculus so that we can find all such areas. Now, integrals can also be considered as antiderivatives. That means a process which is the reverse of differentiation. If we know the instantaneous velocity of an object, then its position at any instant can be determined. If a function is differentiable in an interval, then f'(x) exists. If f'(x) is given, do you think that you can find out that function also? Yes. This function is called antiderivative, means which is reverse process of differentiation, and this process is named as integration. Integrals as antiderivatives. So integral calculus is developed due to the following two requirements. To obtain a function if its derivative is given to you, which we are discussing right now, which is called antiderivative. This is called indefinite integrals. We have two types of integrals. So this is first category, indefinite integral. To obtain area bounded by the graph of a function under certain conditions. And that type of integration is known as definite integration, definite integrals. Now both these integrals, they combine and we get integral calculus. So in today's session, we are going to learn very basic of integration for integral calculus. So you are very well aware of this differentiation, that derivative of sin x with respect to x is cos x. So this process is changed. This process is reversed, means integral of cos x dx is sin x. This sin of dx, that becomes integration sign. This sign is called integration. This sign is known as integral, integration. This cos x is coming here. This dx is also shifting to this side. This shows with respect to variable x. So integral of cos x with respect to x is sin x. So this is called antiderivative. Now what about this function? Derivative of sin x plus 2 with respect to x. This is also cos x. That means integral of cos x can also be sin x plus 2. We take one more function, that the derivative of sin x minus 5 with respect to x is cos x. This also implies that integral cos x is sin x minus 5. Now what's this? That math says unique answers. But now integral of cos x with respect to x is giving us 3 different answers. This cannot be done. So what about these 3 different answers? How can we arrive at a common consensus? So we have to use plus c, which is an arbitrary constant, which is a real number. This is named as constant of integration. Like in the first case, you can see sin x plus 0. In the second case, you see sin x plus 2. In the third case, you have sin x minus 5. So all these constants, plus 0, plus 2, minus 5, and all such infinite constants are clubbed together and we name it as C, the constant of integration. So integral of f dash x dx is equal to fx plus c, the constant of integration. So let's start indefinite integrals now. So if integral of fx dx is fx plus c, the antiderivative or primitive. So let's know about some of the terms which are there for integration. This symbol, this is called integral. This function fx is named as integrand. This x is known as variable of integration, dx with respect to x. Then coming to answer, the answer is fx. This is called antiderivative. This c is named as constant of integration. So these are the various terms which are attached to indefinite integrals. Let's proceed further by learning geometric interpretation of indefinite integrals. We know that geometrically differentiation represents slope of a unique tangent to a curve at the given point. So now what is represented by integration, which is antiderivative? So let's do this with an example. Derivative of x square with respect to x is 2x. You know that? That means integral of 2x with respect to x will become x square and plus c, the constant of integration. So now if we plot y is equal to x square, then what does it become? It's going to give you one parabola which is having its vertex at origin. If you plot different values of this antiderivative, means C will take different values, 0, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. That means you are going to get different parabolas, and all these parabolas are named as family of parabolas, and they represent different values of C along with x square. So let us consider the intersection of all these parabolas by a line x is equal to a, for a is equal to 0. So then dy by dx will represent all these points of intersection, which will be equal to 2x. And tangents to this family of parabolas are also parallel. Let's understand this particular concept by using this figure. You can see that this curve is y is equal to x square. If you wish to plot y is equal to x square plus 1, shift the vertex to 1 unit above the origin. Similarly, y is equal to x square plus 2, shift 1 more unit more from y is equal to x square plus 1 towards along with y-axis. Similarly, y is equal to x square plus 3 can also be plotted. And the same process can be used for getting the graph of y is equal to x square minus 1, x square minus 2, x square minus 3, and this process is infinite. And all these blue parabolas, they are family of parabolas y is equal to x square plus minus c. Now plot a line over here. This is vertical line x is equal to a. So you can check its intersection with all these parabolas and make a tangent, which is shown here in the dotted line. You can see these intersection points are also having the same relationship. This is called geometric interpretation of indefinite integral. They represent family of the given curve, which you obtain as antiderivative. Now, what do you think the difference can be there with differentiation and integration? Definitely, they are two different things, yet they are connected, but still these are two different concepts. So the process of differentiation and integration are inverse processes of each other. The derivative of a function is unique, but integral of a function is not unique. Why so? Because we have fx plus c. The constant of integration gives variety of answers. It gives family of curves. The derivative of a function at a point determines the slope of the tangent to the curve. But integral function represent family of the curves. We have just seen by using that graph. Now let's start integrals as antiderivatives. We have one derivative and we learn its antiderivative or integral at the same time. You can recognize this function, this algebraic function, the derivative of x raised to power n divided by n plus 1 is x raised to power n. Hope you are able to recall how you get this derivative. So if you wish to differentiate this, how do you differentiate it? You write n x raised to power n minus 1. This whole divided by n plus 1. You remember? So this derivative, is it making it x raised to power n? Yes. So its antiderivative will be this quantity. Since derivative is, since you can see the derivative of x raised to power n divided by n plus 1 is x raised to power n. So we can say that integral of x raised to power n is x raised to power n divided by n plus 1 plus constant of integration. And this formula is not workable when n is equal to minus 1. Why so? We learn later in the same session. So if we have derivative of x as 1, so what will be its antiderivative? So antiderivative of 1 will become x. Or you can say integral of 1 with respect to x will become x. Let's have one or two examples based on this. For example, if you wish to integrate x square with respect to x, how will you do it? You use this formula which has been inserted here. So it becomes x raised to power 2 plus 1 divided by 2 plus 1 plus c. So this becomes x cube divided by 3 plus c. Let's have one more example. How will you integrate 1 upon x to the power 3? This can be written as integral of x to the power minus 3. So integrated by using the same formula, it will become x to the power minus 3 plus 1 divided by minus 3 plus 1 plus c, of course. So when you solve it, you will get x to the power minus 2 divided by minus 2, which can be rewritten as minus of 1 upon 2 into x square. This power minus 2 will make it 1 upon x square and plus constant of integration. Let's proceed further with more derivatives. You are very well aware that derivative of sin x with respect to x is cos x. So integral of cos x dx will be sin x plus c. Similarly, derivative of minus cos x is sin x. Integral of sin x is minus cos x plus c. Derivative of tan x is sec square x. So integral sec square x dx is tan x plus c. You can see the relationship between derivative and antiderivative. So these are standard functions. If they are given in any question, you can write their direct answer. Let's learn more. Derivative of minus cot x is cosec square x. So integral cosec square x is minus cot x. Derivative of sec x is sec x tan x. So integral sec x tan x will become sec x. Derivative of minus cosec x is cosec x cot x. Integral of cosec x cot x will become minus cosec square x. Derivative of sin inverse x is 1 upon root of 1 minus x square. So integral of 1 upon root of 1 minus x square will be sin inverse x. The same expression will be obtained if you have minus of cos inverse x. So the same is happening with the negative sign with minus cos inverse x. Derivative of tan inverse x, 1 upon 1 plus x square. So integral of 1 upon 1 plus x square is tan inverse. Derivative of cot inverse x is minus 1 upon 1 plus x square. Or you can shift negative sign to this side for the same thing. So integral of 1 upon 1 plus x square can also be minus cot inverse x. Just take care of this negative sign. If this is there, so you can get the same answer. Maybe tan inverse x or minus cot inverse x, depends on your needs according to the question. So same is happening with sec inverse x. Its derivative is 1 upon x root of x square minus 1. So integral of 1 upon x into root of x square minus 1 is sec inverse x. And the same will be there with a negative sign for cosec inverse x. Log of mod x. Why mod x? Because logarithmic function is defined on non-negative real numbers. It's defined only for positive real number. So log of mod x, its derivative is 1 upon x. So integral 1 by x dx is log x plus c. Derivative of exponential function e raised to power x. Its answer is ex. So its integral is also going to be ex. So this exponential function e raised to power x is the only function which has its derivative and integration both have the same answer, e raised to power x. Derivative of a raised to power x divided by log a is a raised to power x. A raised to power x is an exponential function. So integral of a raised to power x will be a raised to power x log a plus constant of integration. So all these are standard functions and you can use them as a formula also. Let's learn some basic properties of indefinite integrals. The process of differentiation and integration are inverse of each other. So, if you get derivative of integral of fx or fx, then it's also equal to integral f dash x is equal to fx. It's one and the same thing. If you have two functions which are plus or minus of, and you have to calculate its integral, you can calculate their integral separately. If you have a constant multiplied by fx, then you can write this constant outside the integral sign, and then you can integrate the given function. Answer is going to be the same. Let's try a few of the questions. Like first question is, write antiderivative of function cos 2x by using the method of inspection. This is a very objective type of question. So you start thinking in this process. Since derivative of sine 2x with respect to x is 2 cos 2x. How it's coming? It's coming by using chain rule. Means derivative of sine 2x with respect to x. Since you know the derivative of sine x is cos x, but it is not sine x. Instead, you have sine of 2x. So you have to apply chain rule because this is a composite function. So differentiate it like this. This will become cos of 2x. And then what you will do is you multiply it with derivative of 2x. So answer is going to be this. Then cos 2x. Answer will become what? Half derivative of sine 2x. This 2 has been shifted to this side. And you can even shift this half to inside sine 2x. So cos 2x is actually derivative of half sine 2x. So antiderivative of cos 2x will become half sine 2x. This is called method of inspection, by using which you have to find antiderivative. But you can find integral of any function straightforward also by all the formulae that you have just learned as antiderivatives. So this is the question given to you, that find integral of ax square plus bx plus c with respect to x, of course. So you can split them like this, that integral of ax square plus integral of bx plus integral of c. Since a, b, c are constant, so you can write them outside the integral sign. Means ax square integral can be written as a multiplied by integral of x square. Similarly, b into integral of x plus c into integral of dx. So integral of x square is x to the power 2 plus 1 divided by 2 plus 1. That will give you x cube plus 3. Similarly, b into x square plus 2, c into x plus constant of integration. That will become the answer. Moving further to the next question. This is the question, x square multiplied by 1 minus 1 upon x square. So you see that this function is not that much simple, but you can always make the function simpler before integrating it. Like you can multiply them. X square is multiplied to 1, you get x square. X square is multiplied to 1 by x square, you will get x square into 1 by x square. So this x square will cancel this x square and you will get 1 only. So actually you have to integrate now x square minus 1. So integrand is x square minus 1 now. Integrate it like this. So integral x square is x to the power 3 divided by 3, and integral of dx is minus x, because negative sign is here, plus constant of integration. So that becomes the answer. Moving further to the next question. This is the next question. Again, you can see that this is not a simple function. It doesn't seem to be, because it is sort of a minus b whole square. So since it's a minus b whole square, why not to apply that identity? It becomes a square minus 2ab plus b square. Again, you can see in the process, this root x can be cancelled from numerator and denominator, and your function will reduce to a simpler version. Means you have to integrate only x root x whole square minus 2 plus 1 by root x square, that is 1 by x only. So these are just three terms to be integrated. So it becomes like this. You can write like this, and if you feel that you can integrate it directly, so this step is optional. You can leave the step also. So it becomes integral x as x square by 2 minus 2 into integral dx, which is x, and 1 by x. Integral is log of mod x. Why this modulus x has been emphasized here? Because logarithmic function is defined on positive real number and plus constant of integration. So that becomes our final answer. Moving further, question number 5. So this is the question given to you this time, that integrate 1 minus x multiplied by root x. So in place of considering it as a product of two functions, multiply means root x is to be multiplied by 1, then root x is to be multiplied by x. So you'll get this function. When you simplify the exponents of x, you'll get x to the power 1 by 2, and here x to the power 1 plus 1 by 2, because bases are same, so powers get added up. So this becomes x to the power 1 by 2, and this becomes x to the power 3 by 2. When you integrate them, it becomes x to the power 1 by 2 plus 1 divided by the same exponent, x to the power 3 by 2 plus 1 divided by 3 by 2 plus 1 plus c. Simplify these powers, you'll get x to the power 3 by 2 divided by 3 by 2 minus x to the power 5 by 2 divided by 5 by 2 plus c. Simplify this like this and give your final answer in the simplest form. This is next question. Now this root x is being multiplied to another function, which is 3x square plus 2x plus 3. So multiply them actually like this and deal with powers of x, means exponents of x. So bases are same, so you can easily add all the powers. Like this becomes x to the power 2 plus half. Second term will become x to the power 1 plus half. Third term will become x to the power half. When you simplify all these exponents, you'll get this function to be integrated, which is 3 into x to the power 5 by 2 plus 2 into x to the power 3 by 2 plus 3 into x to the power 1 by 2 only, because it has nothing to be added or subtracted. Let's integrate them. 3 is a constant, written as it is. X to the power 5 by 2 plus 1 divided by 5 by 2 plus 1 plus 2 into x to the power 3 by 2 plus 1 divided by 3 by 2 plus 1 plus 3 into x to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus constant of integration. You have to write constant of integration in the same step when you have integrated all the terms. So this will become after adding up all the parts, like 5 by 2 plus 1 becomes 7 by 2, 3 by 2 plus 1 will become 5 by 2, 1 by 2 plus 1 will become 3 by 2. So adjust all these denominators and write your answer, give your answer in the simplest version possible. So this becomes the answer. Moving further to the next question. This time you are given a rational function, means it becomes a bit more tough. But if you look at the function, look at the integrand carefully, you'll see that you can express it in this way. You split the numerator like this and write the reverse process of LCM. You can consider this step as a reverse step of taking LCM of fractions or any numbers. So it becomes x cubed by x square, 5 into x square by x square minus 4 divided by x square. You can see that this x square and this x square can be cancelled, and this x square is actually cancelling out this exponent. So you will get x plus 5 minus 4, and this 1 upon x square can be rewritten as x to the power minus 2. Now integrate all three terms. Its integration will become x square by 2. 5, its integration will become 5x, and 4, an integration of x to the power minus 2. See here, it will become x to the power minus 2 plus 1. So that will give its exponent as minus 1 divided by minus 1. So you just adjust all these negative signs and x to the power minus 1 like this and give your final answer in this manner. Let's move on to the next question. This question is x cubed plus 3x plus 4 divided by root x. So what you can do is you can split the numerator and you can easily plus or minus the exponents of x. So it is 3 minus half, x to the power 1 minus half, 4 into x to the power minus half only. So simplify these exponents for the first and the second term. So you will get x to the power 5 by 2, x to the power 1 by 2, x to the power minus half. Integrate them by using the formula integral x raised to power n dx is x raised to power n plus 1 divided by n plus 1. And this will become the integration, the answer, and you adjust all the exponents and you can give your final answer like this. Moving further to the next question. Now this time, in place of having single term in the denominator, you have got two terms, x minus 1. Now how will you simplify this rational function, or how will you integrate this function? This doesn't seem to be easy, but focus here on numerator. You can check out these terms, x cube minus x square, and you can take x square as common. So it will become x minus 1 plus 1, x minus 1 divided by x minus 1. Now you know the next step, and you have converted this not so easy question to an easy question. You can factorize the numerator like this, x minus 1 multiplied by x square plus 1, and denominator is same, x minus 1 only. So before integration, cancel out all the common factors, maybe constants, or maybe variables, or maybe factors, whatever it is. And your function will always be reduced to a simpler function. Now check this function again. This is the given version to you, which was supposed to be a bit tougher. But here you'll find that this has been reduced to such an easy function. You integrate x square, you will get x cubed by 3. When you integrate 1, you will get x plus constant of integration. So that becomes a final answer. Moving further to the next question, number 10. The 10th question is this. Integrate these four functions which have been plugged to make a single function. X by 2, 2 by x, x raised to power 2, 2 raised to power x. How will you integrate all these? So this is 1 by 2, integral x. 2 is a constant, write it here. Integral 1 by x dx, integral x square, and integral 2 raised to power x. All these are simple and standard functions to be integrated, yet they have a different approach. Like integral x, use this formula, x to the power 2 divided by 2. 1 by x, integrated as log x. X square, use the same formula of x raised to power n. It will become x cubed divided by 3. And this 2 raised to power x is exponential function a raised to power x. So its answer is also direct, 2 raised to power x divided by log 2. In the calculus, we take log to the base e. So always you have to go by log to the base e. So if it's mentioned something else as base, then you have to change the base as well. So final answer is clubbed by writing this 2 and 2 into 4. This 2 raised into log x can be written as, like this 2 can be shifted to power of x, it will become log of x square. And since x square is going to be positive always, so you can remove this modulus sign and you can use any bracket if you wish. And x cubed by 3 and 2 raised to power x upon log 2 will be as it is, and this will be your final answer. Question number 11. So e raised to power 4 log x minus e raised to power 3 log x divided by e raised to power 2 log x. This type of function. So look at the function again. So if all these things are given to you, like 4 log x, 3 log x, 2 log x, so you can use property of logarithm to write them like log of x raised to power 4, log of x raised to power 3 and log of x squared. And this will make our task easier because e raised to power log x is equal to x. Log to the base e is here. So e raised to power log to the base e will give you answer as x. So this property has been utilized here. So it's going to be x raised to power 4 minus x raised to power 3 divided by x raised to power 2. So you can cancel out this x square like this. And then you have to integrate only x square minus x. Integral x square is x cubed by 3. Integral x is x square by 2 plus constant of integration. A question which was supposed to be, which seems to be so tough, has actually been reduced to such an easy version. And you know that you have to apply these two identities of exponential function and logarithmic function. So integration is very easy and very interesting.
And yes, ma'am, as we are proceeding towards the 12th question, let me inform you that we are just left by 9 minutes. We'll try to make it a bit quick. Ma'am, you may proceed with the next question.
So question number 12. Integrate sec x multiplied by sec x plus tan x. How will you integrate this? So if we actually multiply these two functions, we'll get sec square x plus sec x tan x. These are two standard functions. Integral sec square x is tan x and integral sec x tan x will be sec x plus constant of integration. So question is too easy. This is again objective question. Moving further to the next question. 2 minus 3 sin x divided by cos square x. So you can split the numerator like this. And then you use your basic trigonometric ratio that 1 upon cos square x is sec square x. Sin x upon cos square x can be rewritten as sec x into tan x. And integral sec square x is tan x. Integral sec x tan x is sec x. Of course, constants 2 and 3 will take their places, plus constant of integration. Moving further to the next question, integral of sec square x plus divided by cosec square x. So reduce them to very simple version. Means sec square x can be rewritten as 1 by cos square x. Cosec square x can be rewritten as 1 upon sin square x. So arrange them like this. Take reciprocal of the denominator. Actually, you are getting tan square x. Is tan square x derivative of some function? No. So you cannot integrate it. Convert it into sec square x minus 1. The identity is sec square theta is equal to 1 plus tan square theta. Use that identity to convert tan square x into sec square x minus 1. So sec square x has integral as tan x minus 1 has integral as x plus constant of integration. Question number 15. Integrate square root of 1 plus sine 2x. How will you integrate this? Can we express this 1 as sine square x plus cos square x? And this sine 2x can be written as 2 sine x cos x by using identity of sine 2 theta. Now, this function written in the square root, these three terms, they become square root of sin x plus cos x. So this square root and this power 2, they cancel each other and you have got integration of sin x plus cos x. So integral sin x is minus cos x, integral cos x is sin x plus c. We have seen in the beginning of the session that they are standard functions and their derivatives or their antiderivatives are related in this particular manner. Moving further to one more question, that 1 upon sin square x into cos square x is integrated in different ways. So the method which is taken here is like 1 is to be converted into sin square x into cos square x. And this is divided by sin square x multiplied by cos square x. So split the numerator like this. And here cancel out the common terms. Like sin square x is being cancelled here. And in the second term, you can cancel out cos square x. And it will lead to 1 upon cos square x plus 1 upon sin square x, which will become sec square x plus cosec square x. These are standard functions. We have their formulas with us. So it becomes tan x minus cot x plus c. Let's do one more question. Integral of cos 2x minus cos 2 alpha divided by cos x minus cos alpha. Do remember that in alpha is a constant. Only one variable is here, which is x. 2 is also constant, alpha is also constant. So apply the identity of cos 2 theta. Cos 2x will become 2 cos square x minus 1. Similarly, cos 2 alpha will become 2 cos square alpha minus 1. And simplify them. So this minus 1 and this plus 1, they cancel out each other. And you will get only 2 cos square x minus 2 cos square alpha in the numerator. Take out this 2 common and you will get a square minus b square in the bracket. So apply the identity a minus ba plus b and this common factor cos x minus cos alpha can be cancelled from numerator and denominator. And we have to integrate only twice of cos x plus cos alpha. Integral cos x is sin x and cos alpha is a constant, so its integral will become x, and cos alpha is a constant, it has to be written as it is, and plus c, the constant of integration, is to be written.
And ma'am, as we are left by just 3 to 4 minutes, we will try to make this the last question for the session.
Okay. So last question for this session is this inverse trigonometric function. So this is very simple question. It has just 2 steps. Cos inverse sin x. So do we have any connection between sin x and cos x? Yes, we have. We can apply this identity. That sin x can be represented as cos of pi by 2 minus x. So you can recall this identity. Cos pi by 2 minus theta is sin theta only. So we have applied this identity. And this cos inverse and cos will nullify each other and will be left to integrate only 2 functions, pi by 2 minus x, out of which pi by 2 is a constant. So you integrate pi by 2, the integral dx is there, answer will become x. Integrate x, it will become x square by 2 plus constant of integration. So that completes this question as well.
Yes, ma'am, and very nicely you have explained it with the help of different numericals, with the help of different concepts. Integrals are quite clear in front of us, and I hope for our audience as well. I would like to thank ma'am for connecting with us. Thank you, ma'am. Thank you so much. In this session, we discussed about definite integrals, indefinite integrals, properties of indefinite integrals, geometric interpretation of these integrals, integrand, and also the difference between derivation, differentiation and integration. Once again, thanks to everybody who has connected with us, and also thank you ma'am for being here with us. Stay connected to NCERT. We will be wrapping this session, but we will be coming with the upcoming sessions in our latest days. Thank you so much. Stay connected.